first part of Chapter 2, we're going to talk about what you do once you've collected qualitative data. You have a whole bunch of data. When you first collect data, it's essentially just a mess. So you have to look it over and organize it. Now, if I gave you data of a qualitative source, which means essentially a whole bunch of words, and I asked you to organize it for me, I think most of you would pretty much do what I need you to do without any instruction. So this part should be pretty easy. Basically, you would make a 2-column chart, and on the left-hand side, you would list all the answers that you got. That was the data. The data is the answers that you collected to the question that you asked. On the right-hand side, you would put how many times you got that answer, so we call that the frequency. Right-hand side is always going to be numbers. So when we talk about when you decide whether our data is qualitative or quantitative, remember, you're only looking at the left-hand side. So here's some frequency distributions, and if you see the one on the very left that has a list of pets, notice in the left-hand column it's a bunch of words. A bunch of words means the data is qualitative. The fact that we have numbers on the right-hand side just tells you how many people had dogs, how many people said cat, how many people had a guinea pig. The test, where I have a list of grades, A, B, C, D, F, those are words. That is qualitative data, again, even though on the right I have numbers. The last chart, the one that says number of vehicles, there are numbers in the left-hand column. Numbers in the left-hand column indicate quantitative data. It's only what's on the left-hand side that tells you what kind of data you have. Now I have a list of data here. I have 20 responses from, a satisfaction sheet from 20 people who stayed at the hotel. And I want to make a graph out of this so that I could show my boss we're doing a good job. Well, before I can make a graph, I have to make what's called a frequency distribution. So the data are those below average, above average, excellent, etc. responses that I got from my little satisfaction cards. That's my data. It is qualitative. Before I start making a chart, I need to also decide, is it nominal or ordinal? Well, if I look in the description here, it says that people could rate the quality of their accommodations as being excellent, above average, average, below average, or poor. That does have a progression to it, from happiest to saddest. So since my data has an order to it, when I make my frequency distribution, I want to keep that order. So when I look at my chart and I'm going to start listing my ratings, I want to list my ratings as such. Excellent, above average, average, below average, and poor. Now I could do it the exact opposite. I could start at the worst ratings and then go to the best. But that's just not good business. You want to accentuate the positive, and hopefully they lose interest before they get into the bad responses. Now, you want to pause this, because after you have your actual data listed in the left-hand column, in the frequency column, you just need to count up how many times each one of those happen. So before I click and show you, pause and count those bad boys up. That is what you should have gotten. Now, one thing that it's always a good idea to do, once I've made that frequency distribution, I need to add up this column. The other page said I had 20 responses. My frequency needs to add up to 20. If it doesn't, I counted something wrong. Now this still won't tell you if you put the stuff in the wrong place, but at least it'll tell you right off the bat whether you're missing anybody or not. Now for the relative frequency is just a percent. So to find the relative frequency for each class, each group, each response, the first one, excellent, that's just 1 divided by 20. One response out of 20. On a calculator, change that to a decimal, and then change that to a percent. And you want to do that for each category. Again, you may want to pause for a minute and go ahead and compute those. And there's the answers you should have gotten. Now, one thing that I want to make clear, these first two columns, that's frequency distribution. This column is extra. You only do that if you're asked to do it. It's a good way to bring up the vocabulary word without having to do a whole nother set of data, so we just went ahead and did it. But you only do the relative frequencies if you're asked to, because these first two columns are what I need to make a graph. And one of the graphs that I can make from qualitative data is a pie chart. Now this pie chart is a horrible, horrible pie chart, because while the colors are kind of pretty, it doesn't tell you anything. Pie charts should tell you two things: what the answers were and the percents. Now, if you look at these little bitty squares, I'm supposed to match up these colors with the different slices of pie so that I could tell which of those slices of pie are good or which of those are bad. You never want the person reading your graph to have to work too hard. That thing down there is called a legend, and we never want it. Now the other thing, even though I could see which pieces of pie are bigger, it'd be nice if they went ahead and told me what percent was each. That one's a little better. This one, at least I can tell the percentages. But again, I never want to have a legend, because even though now I can tell what percentage piece is, I still can't tell which are the good responses and which are the bad responses. That's your award winner. Notice, it may not look as exciting as the one on the right because I took out all the shading and stuff, but I can look at this pie chart and I can tell everything I need to know between the title and the fact that the responses and the percentages are right there on the pie, and I don't have to play match game to figure it out. That's what tells me that's a good pie chart. It makes the point. I could tell right away that half the pie over here is excellent or above average. And if I put in the average, that's 3/4 of my pie. 3/4 of my responses were average or better. That's the kind of thing that you want to be able to do when you're looking at a graph, is be able to tell, am I impressed or am I not? Because I don't have time to figure out what you're trying to tell me. The second kind of graph is a bar chart. A bar chart has the categories along the x-axis, and if there was an order to those categories, you maintain the order. So again, you could say everything over here, those are the good responses compared to those pitiful two little bars over there that were not so happy. Bar chart maintains the order. A bar chart is made for ordinal data. Now, I have, what's your favorite color of M&M? Colors, that's nominal data. I can list those colors in any order I want to. I could make a graph, or I can make a chart, frequency distribution with red first, or I can make a frequency distribution with orange first, and nobody would argue about that. So, when you have nominal data, it is customary to put it in order of most popular response first, and then you stair step down. So most popular, then your second most popular, then your third most popular, and so on. So what happens here is you almost have to make like a first draft, rough draft of your frequency distribution, because just looking at it, you're not going to be able to tell just from your mixed up data which happens most often, which happens second most often, and so on. So go ahead and pause this and see if you can get this organized, and you have your most popular first, second, third, and so on. This is what you should have gotten. Now brown and green are tied. They both have 5, so those could be switched around and it wouldn't matter. But there's your frequencies and then your relative frequencies. Point that I want to make here, I'm very consistent. I'll always ask you for your relative frequencies to go to 1/10%. StatLab may not be quite as consistent, so make sure you read the directions on my StatLab to see how many decimal places you should go to. Now I could make you another pie chart out of this one, but that's really not the point. I wanted to show you this was not ordinal data anymore. This was nominal data. And when I make a bar graph out of nominal data, it looks a little different. Since I always arrange my data from most popular to least popular, my data is always going to stair step down. When I have a bar chart that's arranged so that it stair steps down, that's called a Pareto chart. So a Pareto chart is still a bar chart, but it's a specialized kind where your data was nominal, so you put it in order from most popular to least popular.